All right, so I have shared my whiteboard. Okay, let's talk about Argand diagrams today. Okay, so let me just take out the questions I wanted to do. All right, so we are going to talk about Argand diagrams. And do not worry about this topic, okay? You would understand things in today's class, and then when you'll practice questions, I'm pretty sure that you would be able to do a good job, okay? Let's start with the basics. From where exactly these Argand diagrams are coming? They're coming from complex numbers, okay? So we know that we can represent a complex number two ways, right?
Yes.
Okay. All right. So right. So let's say you have a complex number of this type z equals a plus b iota. Now we have discussed two types. Either the complex number would be in this type or it would be in the polar form. Let's see how to plot these two. Now this is the simplest case. So let's take an example. Let's say we have 8 minus 2 iota. Okay. So let's talk about the plotting of the complex number if it is given in this way. It would be a point only. This is the imaginary axis. This is the real axis. Okay. It would be a point only where the real coordinate is 8 and the imaginary coordinate is minus 2. Okay. So this is minus 2 and let's say this is 8. So this is going to be the complex number z equals 8 minus 2 iota. Any confusions with this?
No.
Okay, very good. Now this is the representation in this form, okay? What about the polar form? How do we convert this to polar form, Ranjani? We need two things. We need z mod and the argument, or you can say we need r or the argument. So what exactly is r? R is under the root and then square of both these. I'm just squaring this number and this number, okay? So
Okay.
this is going to be under the root 64 plus 4. So that would be,
That
it would give you
will
2
be
under the root
8.4.
17. Yeah, but let's keep it in this, or maybe I can just, convert it to decimals. Okay, so what exactly it is? 8.25.
8.24.
Okay,
8.2.
5. Okay, right? This is the R or Z mod. Okay, now you should know that Z mod and R, they are same. Okay, right. This is the first thing which we need. And the other thing is the theta. How do we calculate it? Theta is basically tan inverse of what?
Um, Tan
Yes.
inverse of 8.25.
Not exactly 8.25. It is y by x. Okay, it is y over x. So you can just use your calculator, tan inverse, and then just plug in the value of y and then x and just check what exactly it's giving you.
So 2 by 8.
Okay, and what is your calculator's more? Is it in degrees or radians?
Degrees. Oh, it should be in radians.
Yeah, it should be in radians. Very good. Okay. So it is going to be,
It's going to be 0.24. Yeah, 0.24.
okay. First thing is this, Ranjani, that you need to, are you comfortable with trigonometry?
Yes.
Okay. All right. So just understand this through that. Right. So this is 8. This is -2. And what quadrant is it? It is the fourth quadrant, right? When you will find
Yes.
the theta, it is not supposed to be positive. It should be negative. Okay. So you can just either you can do tan inverse -2 divided by 8 because it is -2. Okay. So that would directly give you minus 0.245 radians. Okay. Let's not get into that detail. Just focus on this thing. You said that the answer is 0.245. But if you plug in tan inverse -2 by 8, you would get a
Minus
negative
2.
answer. Okay.
Okay.
Are you okay with it?
Okay.
All right. Very good.
Yes.
Okay. So now I'll plot the diagram again. I'll plot this complex number again using the fact that it is represented in the polar form. Okay. Now when I'll do it, I should know again that here I would be having the imaginary axis. This is the real axis. Now I need to focus on the length of the complex number and the angle. The angle is negative. What exactly negative means? That it would be in the
Clockwise.
clockwise direction or anti-clockwise direction. Sorry, yeah, clockwise. So
Anti-clockwise.
I've basically made the same directions. I'm sorry.
Same,
Okay.
same.
Yeah. Okay. So anti-clockwise or clockwise? Your answer was correct initially.
Anti-clockwise.
No, clockwise. Okay.
What?
This is negative angle, and this is positive angle. Right.
Okay.
Right, Ranjani. You know this. Okay.
Yes. Yes.
Okay. Very good. So 0.245 would be somewhere in the fourth quadrant, and the length, I'm going to make approximate length. This length should be 8.25. So the length is 8.25 and the angle is negative 0.245. So this is the angle and it is negative 0.245. Okay. This is all you need to understand. Yes. Okay. So did you understand the plotting of a simple complex number using two things? So
Angle is negative 0.25 and 8.25 is the
is the radius. It is the length of the
radius.
complex line. Okay. It is the length of this line.
Okay.
Okay.
Okay, yeah.
So are you okay with it? Please tell me honestly.
Yes, it's fine.
Okay. All right. So this is the first thing. Then we'll talk about geometric effects later if we have time. For now, I want to focus on the other things like the circle plotting and all that. The loci basically. So I am going to rub this. All right. Okay. So okay. So Ranjani, here we have basically we need to illustrate the locus of points on the Argand diagram. Okay. This is the idea. Let's talk about the first thing. I'll write down the main statement first and then I'll talk about that thing. Okay. Whenever you have been asked to plot something of this type, it would be a circle. Center of the circle would be AB and the radius would be R. Okay. So you need to focus on this thing. Whenever you come across something of this type where you have mod z minus a complex number, that would give you a circle. The center would be AB, this is A and this is B, and the radius would be R. Okay, right. Now we have this general thing in front of us. So we can think about any circle now. So now I'll write down the example next to it just so things make more sense. So we need to illustrate this equation z minus 4 mod equals 6. Okay. Now, since this is the first case, that is why it would be very, very easy. But once we're done with all the cases, it would get complicated. Okay. So you need to see that what exactly are the things which are basically representing a circle. This thing is exactly this thing. You have mod, you have z, you have a number, and then you have a number here. So this number right here would be the radius
Radius.
of the circle. And what is the center of the circle? The center of the
That
circle
will
is,
negative 4.
let's be careful, okay? Negative 4 is basically outside. So if I make a bracket around it, what do you see? A is 4, A is 4, okay, and B is what?
0.
Very good, okay. So 4 and 0. This would be the center and the radius is 6 and that is it. Now I'll make the axis. This is the y-axis or maybe the imaginary axis because we're talking about complex numbers here. And then I'm going to make the real axis. All right. Now I will make the circle. The center is supposed to be 4, 0. So this would be 4. Okay. And the radius is 6. So my question from you is this, Ranjani. What would be this coordinate and what would be this coordinate?
Um,
Center is 4. The radius of your circle
so
is
that will be
6.
10.
This would be 10. Okay, very good. And this would be
That will be negative 2.
very well done. Excellent. And that is it. That is it. Okay. So is it easy?
Yes.
Okay. Now let me talk about another example. And I know that it is easy because at the moment we have just done one case. Okay. I do understand that it gets complicated once we talk about all the cases and everything, but not that much. Okay. You just have three things here. If you understand all the three things easily, you would be able to make them easily. Okay. So I am going to make another example. So you need to plot this. This. Okay.
Okay.
This is the question. Okay. Now I want you to
Here
plot
the
this.
center is
Mhm.
negative 2 and 8. The center?
Wait a second. Okay, wait a
No, the
second.
center is 2 and 8 because the minus is a part of that.
Yes, but again,
2
think
and 8.
think about it. You close, but think. Okay, listen to me. Okay, let's do this example together. Now, this should be in your mind every time. Okay, this should be in your mind every time. You need to make this equation look like this one first. How? So we have mod, we have z, we have minus. I'll take minus common, and now I have 2 minus 8 iota equals 3. Now I need to think about A. This is A, and B has a positive sign here. This means this negative is with B, right? This is
Yeah,
positive, and here we have minus 8. It means that B would be what, Ranjani?
minus 8.
Very good. And radius would be?
3.
Very good. Okay. So the coordinates of the center are going to be 2 and minus 8. So this is 2 and this is minus 8. So the center would be somewhere here. Okay. Now the radius is 3. So let me make the circle first. Let's set something of this type. Obviously, it's not a perfect diagram, but that's okay. Okay. Now the radius is 3. Okay. So the center has coordinates 2 and minus 8. My question is, one second only. Okay. All right. So, okay. Ranjani, what would be the coordinate of this point? What would be the x coordinate here? The radius is 3. This is 2. This is 2. The radius is 3. So what would be this?
Um, that will be
Mm-hmm. Yes, the radius is 3. This thing is 2. What would be this thing? That's easy.
minus 1.
Very
Minus
good.
1,
Very good. Minus 1. And what about this? If I start, going up like there.
5.
Very good. Good. Okay. Very good. Okay. That is good. And what about this point right here? Mm-hmm.
This point will be minus 5.
Very good. Okay. And what about this one?
That will be minus 11.
Yes. Okay. Very good. Okay. So, are you comfortable with the plotting of circle?
Yes, it's fine.
All right. Okay. So, this was the first thing which you need to understand. The second thing is the perpendicular bisectors. Okay, I'll rub this. Again, I'll make the general thing first. z minus a plus b iota. Now, so far it is just like the equation for a circle, right? In complex numbers,
Yes.
but equals. It is not equal to the radius. It is not equal to a constant number. It is equal to something of similar type. Z minus C plus D iota. Okay. So this is the perpendicular bisector of the points AB and CD. Okay. Now please pay attention. What exactly is happening? This equation, which initially looked like the equation for a circle, but this is the difference. Here we have two similar things. This is the perpendicular bisector of the line that is being made by these 2 points. Do you know what exactly a perpendicular bisector is?
Yes, perpendicular bisector is basically there's a line drawn in between at 90 degrees. So perpendicular.
Yes, and it bisects that line. Okay, very good.
Yeah.
Okay, so let's talk about an example. Let's say the equation in your case is z minus 2 plus 2 iota equals z minus 3 plus 4 iota. Let me just make a difference just so we have something back. Okay. Yeah. This is the question. Okay. Now this is the equation and you've been asked to plot the locus of these points on an Argand diagram. Okay. Do not get scared when you come across the word Argand diagram. It's nothing. It's just a plot. If you know all the cases, you can easily make it. Okay. So here we are talking about perpendicular bisectors. What exactly is the distinction? The distinction is that you have two things and they are written in mod, and this will give you the first point and this will give you the second point. Okay. So what are the coordinates of the first point, Ranjani?
1 and 1,
Very good. And what about the second one?
3 and 4.
Very good. Okay. Now let's make the line that would be made using these points first, and then I'll talk about the perpendicular bisector. Okay. So it is 1, 2, 3, 4. This is the imaginary axis. And then if I talk about the real axis, so it is 1, 2, 3, 4. First point is 1, 1. Then we have 3 and 4. Okay. Now we need a line that is bisecting these 2 points perpendicularly. Okay. So that is going to be, for this, I need to make a line here first. And then later on, I'll rub that line, obviously. So if you have been asked to make a sketch, that is fine. You can just, make it roughly. But if you have a proper grid, then in that case, you need to measure the line and everything. Okay. So
Okay.
I need a line that is not this, obviously, and it should bisect the green line and the angle should be 90 degrees. Okay. So This angle is 90 degrees and it is bisecting the green line. So I am only interested in the pink line. So I am going to rub everything else. Okay, this would be the locus of these points. Okay,
Okay.
right? I repeat,
Yes.
you're not going to make a line connecting these 2 points because this is just representing the perpendicular bisector of these 2 points. Yes, for reference, you can make those points, but you'll come once we do these past papers, you'll see in marking schemes, the examiner is just, or maybe in the model answers, the examiner is just making the line for the perpendicular bisector. You will find a question, maybe a question or two from this thing, because this is not a very popular topic like the making of perpendicular bisectors. But yes, in general, from this topic you will come across multiple questions. Okay, all right, Ranjini.
Yes.
So are you comfortable with this, with the plotting of perpendicular bisectors?
Yes. But without any if they don't give any coordinates, how will we figure out like what exactly is the point of perpendicular bisector?
No, which no, they are going to give you these. What I did not understand the question.
Like, so basically here we know the two coordinates, 1, 1 and 3, 4, and we're
Yes,
supposed to draw the perpendicular bisector. So
exactly.
how are we supposed to draw it like exactly?
This is how we are. Yes, okay, yes, obviously you will use these points first to make the green line I made earlier. Okay, let me just
Okay.
try going back. Yes, without this, obviously you cannot do it. You will make this, but then you need to rub that. And you don't need to make this green line because you can just, or maybe you can just make a line using a light pencil and then just, make a dark
Yeah.
line with the pink one. But obviously, yes, you are right. Without the green line, we cannot make the pink line. Yes, that is true. So you have to make the green line as well. Okay. But then you need to rub it as well
Okay.
because this is only representing the perpendicular bisector. That is it. Okay.
Okay.
So we are just focusing on definitions. All right. Okay. So this is it. Okay. So Ranjani, I'll be back in 1 minute only. Okay. I just need 1 minute. Okay.
Okay. Ma'am.
All right. Okay. Yeah, I'm back. Okay. So this is how we make the perpendicular bisector. Let's talk about the next thing, that is half lines. Do you remember how to make half lines?
Don't.
Okay, it's okay. It's good that we revise all these together. Okay. So I'll try making a chart type of a thing at the end, just so you can keep things in mind. That would help you with memorizing all this. But trust me, if you think about something as an easy topic, things are easy. If you think about something as something difficult, then things get complicated naturally. Okay. Again, I am going to make this. So this is about half lines. Okay, argument z minus a plus b iota equals c. This is a half line. I told you the logic behind half. Okay, half line starting at a and b with an argument of c. Okay, so argument of c means that the angle would be c. 1 second only. Let me make a small box. Okay. This is the rule. And now we are talking about half lines. So a quick recap. So far we know how to make circles. We know how to make perpendicular bisectors. And now we're talking about half lines. Okay. So yes, this is the idea. Let me just talk about an example. So example number 1. Let's say you have been asked to plot the locus of these points on an Argand diagram. Okay. Now, Ranjani, how do we make half lines? I'll tell you. If this is the general thing, they're saying this is a half line starting at AB. So what would be our starting point? This is the thing we
1
have.
minus 2.
No, wait,
Minus 2
wait,
and 0.
wait, wait, wait. No, 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 no. Okay, I told
2
you
and 0.
earlier as
2
well.
and 0.
Yes, okay. First, write it down in the general form. The examiner is obviously not going to do that for you, okay? So it would be 0 iota equals 2 pi by 3. Now this is the argument and this is the point that has coordinates 2 and 0. So it would be, this is 2. This would be the point. I am going to make a line and the angle is 2 pi by 3. So it would be a line of this type and this angle is 2 pi by 3. Okay, that is it. You are not going to extend the line this way. This is why it is half line. I told you earlier as well, the angle is going to change. This angle can only be shown with this line. That is why they're saying it is a half line. Okay. Yes, Ranjini, did you understand it?
Can you please repeat it?
Okay. So the third thing is the half lines. How do we make it? What is the hint? How would you distinguish this from all the other types we have done? This is the biggest thing which you can, use for remembering this. If it says argument something equals this, then obviously this would be the angle. Okay, this would be the angle. 2 pi by 3 means it is positive. Positive means it would be in the anti-clockwise direction. You start from here and you know that this would be pi by 2, this would be pi, this would be 3 pi by 2, this would be 2 pi, and so on, right? So you know these basics. Using these basics, you know that 2 pi by 3 would be an angle of this type, somewhere here. You're not sure exactly, but somewhere there, okay? So that would be the argument. That would be the argument, and this will tell you the starting point. So a plus b is the starting point. We had z minus 2. We do not know how to do. We'll just take minus common. We'll write down a, we'll write down b. This would be the starting point. This would be the argument, and that is it. You are not going to extend the line this way because it is a half line. Okay.
Okay.
Yes. Did you understand this?
Yes.
Are you sure, Anjani?
Yes.
Okay. So we are done with all the things we had to do. Okay. We are done with the simple plots and with these three types. We have done with circles. We did circles, perpendicular bisectors.
Bisector and half line.
Very good. And these are the three things which you need to understand. What we did initially, we plotted a point and that is very easy. The examiner may or may not give that. Okay, we'll see. We'll talk about past papers there. We can just understand the pattern and everything. But for now, the basics should be clear. Since we are done with this, now we can talk about inequalities. So you will see in case of inequalities, we are going to talk about similar graphs, but we would be shading some region. So I'll tell you when to shade which part. Okay.
Yeah, that's where I was facing the most problem.
It's okay. It's okay.
Inequality.
Yeah, it's okay. So now we don't need anything. We don't need to make those boxes. We are done with the general things. Did you write everything, Ranjani?
Yes.
Okay, that's good. Okay, let's talk about the very first example. So it is Z mod greater than 4. Okay, so please pay attention. This is Z mod greater than 4. Okay, now step 1 is to eliminate the inequality sign and put the equality sign just for your understanding. So it is Z mod equals 4. This is the solution. You know what exactly it is? What is this? This is the equation of what, Ranjani?
This is the equation of a circle.
Yes, that is very obvious. We have done 3 cases. Help me write down the 3 cases first.
A circle, perpendicular bisector, and half
Yeah,
line.
yeah, yeah. But what exactly have we done? A plus B iota mod equals R. This was for
This was for a
circle.
circle.
Okay, please, this should be clear now. And then
Yes.
Z minus A plus B iota
Yeah,
equals,
equals the same thing
yeah,
is
different
perpendicular
with
bisector.
different coordinates. Okay,
Yeah, with different coordinates is perpendicular bisector.
very good.
And you write the same equation as circle, but instead of the radius, you have like,
The same thing.
yeah, same thing, but with arg arguments. So that'll be half line.
Okay, ARG and then Z minus A plus B iota equals C. So this would be a half line. Okay, all right. So this is a circle, certainly. Okay, I'm going to make the circle quickly. This is the imaginary axis. This is the real axis. What would be the center of the circle, Ranjani?
Zero, zero.
Yes, just say that with certainty. Okay, it would be 0, 0. And the radius would be what?
Oh,
Okay, it is an oval shaped circle, but it's okay. It is 4. So this would be what? This would be what, Ranjani? What would be this and what would be
4
this?
minus 4, 4 minus 4.
Very good. Okay. So we are done with this. Now I can rub this. Okay. What exactly it says? It says this is greater than 4. You have the greater than sign. Okay. Whenever you have the greater than sign, you will shade what?
Outside the circle.
Yes, very good. Outside the circle. Okay. So I don't know how to shade it. Let me make a box. Okay. Now I can shade everything outside the circle. Right, Ranjani? Always remember this is representing outside. This is representing the boundary of the circle only. And this is representing
Side.
inside. Okay. So are you clear with the 3 cases of circle?
Yes.
Okay. Very good.
What if something like less than or equal to? Then everything?
Very good. I'll tell you. Then no, 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 less than or equal to. No, no, no. Wait a second. Okay, I'll tell you. Here, um, I should have just made the circle with a dotted line, right? Once you're done with it, just try rub some parts just to make the circle in a dotted way. Now I'll tell you. If you have less than, sorry, if you have greater than only, you'll shade outside part only. Okay, and the color should be same. I should have used same colors, but it's okay. If you had less than or equal to, I would have used a dotted line, and I would have used a solid line in that case, because in that case the boundary was also included. Okay, the only difference this would make is the line would become solid. Okay, otherwise in this case, in our case, we are just gonna make a dotted line. Okay, but as soon as with the inequality, equality adds up. Like this is basically inequality and this is equality as well. So the basic shape would be a solid line. Okay, let's talk about an example of this type. Let's talk about two examples. Z mod is greater than 2 and Z mod is less than or equal to 4. Okay, again, first I need to write down the equation and I need to make the corresponding diagram. I know that these are two circles with center 0 0 and radius 2, and here the radius is 4. Okay, let's talk about this first. This is greater than, so I am going to shade everything outside the circle, and the boundaries of the circle are not included. So first I am going to make the boundaries dotted.
Because that's not included.
Yes, okay, very good. And then I will just shade everything outside the circle. Okay, yes, Ranjani, is this okay?
Yes.
Okay, it should be proper. Yes, okay. In this case, Z mod is less than or equal to 4. Now it has equal to in it. I'm not going to make the solid line dotted. It is going to be a solid line. Okay. So it is inside because we have less than. So I am going to shade all this, and the boundary of the circle would also be included. Right? Is this okay, Ranjani?
Yes.
Okay. Are you sure that you have understood this?
Yes. Here it's not dotted because the boundary is also included.
Yes, it's not bounded because we have less than equal to. Okay. If this is confusing you, then I can just maybe
No,
just
it's
write.
it's fine.
It's fine, okay. You can just note it down,
It's
okay.
fine.
Less than equal to means what, greater than equal to means what, equal to means what, less than means what, greater than means what, okay?
Yes. So
Okay.
basically, if it's less than or greater than, you draw the circle like in dotted line and
Yes.
shade the outside or inside portion
Yes.
respectively, depending on whether it's greater or less than. But if
Exactly.
it's greater than or equal to, you don't make the circle in a dotted line.
Exactly. You
It's
use a solid
solid
line.
line, and then you just shade it. Okay.
Yes, that is correct actually. Okay. So are you okay
So
with
even
it?
in equal to case,
Sorry?
it's if it's
Equal to?
modulus of z equal to, then
Yeah.
also is a circle dotted? No,
No,
right?
no, no. It's a solid circle. Okay.
Okay.
If it is z mod equals to 2 equals to 4, it would be a solid circle, just like we did in the very beginning.
Okay.
All right. Now I'll write down a question and I want you to try it. Z minus 7 less than z plus 3 iota. It's okay if you are not able to do the inequality. At least you can try making whatever you get for the equality. Okay.
Okay.
So I'll give
This
you
is
a
the
minute.
perpendicular bisector one.
Yes, very good. Excellent. Okay. Just make the shape and you can just send me the picture. Okay. I'm waiting.
Okay. Ma'am, are the coordinates negative 7, 0, and 0 and 3?
Yes, it would be 7 and 0, and it would be 0 and minus 3. Okay. Take minus out first.
Yeah, 0 and minus 3.
Yeah.
And negative 7 and 0.
Not negative 7, Ranjini. Just take minus common first. Okay. Just take minus common first.
Okay, yeah, I got it. Ma'am, I have sent it to you.
Yes, Ranjani, are you done?
Yes, I have sent it to you.
Okay. Let me just check. Okay, so you have sent the okay, all right, very good. Okay, perfect. Okay,
Now it says less than,
okay. Yes, just
so
one
it
minute.
will be
Mm-hmm.
on the left hand side of the perpendicular bisector, that region.
Okay, so let me just one minute only. Okay, you were saying left side, right?
Yes, because it's
Okay.
no.
Wait a sec. Wait. I'll tell you. So basically, I will just make the line first. It is this is what you have sent me. It would be something of this type. Okay. For the exact plotting, you need to understand one thing. Okay, I told you earlier as well that the shaded part would basically be decided on the basis of the sign. Okay, so one point was 7 and 0, and then the other one was
0 and -3.
yes. So it would be yeah. This is here. I'm sorry, and then it was here. Okay, all right. So you need to decide this according to the sign. Okay, all right. So Ranjani, when we were doing it earlier as well, I told you that for this inequality, in case of um, perpendicular bisectors, you need to shade according to the point that is closer, right? Do you remember this?
Yes.
Okay. So we are going to shade this part. Okay. Your hint is that whatever side whatever side is less than this was the point 7 and 0. Okay. Whatever side is less than, just shade that, because
Okay.
the complex numbers that here we're talking about are closer to this than this. Okay, that is why we're shading that part, and this is going to work every time. So all you need to do is just make the line, just see where exactly is the lower side. This is the lesser side or the lower side, whatever you want to call it. The coordinate, the point coming from this side was 7 0. Okay, so just shade this, right? If you think about it, the way we've been plotting circles, the way we've been plotting other things, yes, in that case I'm sure that this is why you were saying left side. I know that this makes sense. Okay, but since we need to understand that we are not talking about these points exactly, we are talking about the perpendicular bisector. Okay, so things are inverted. Are you getting my point?
I get it.
Okay, so the logic is, because if you get into too much details, you might get confused. Okay, so all you need to do is just make the perpendicular bisector. Once you're done with that, just see which is the lesser side and just shade that. That is it. Okay,
Okay.
so are you okay with it?
Yes.
Okay, Let's talk about the last one, the last thing that is left. Example number 3. So you need to plot pi by 6 less than argument of z less than pi by 2. Okay. Now, what is this? This is a half line. Okay. We have been doing this, and this is also a half line. Okay. So you can make two lines using argument of z equals pi by 2 and argument of z equals pi by 6. For this line, what would be your center? What would be your center, Anjani?
Center would be
It's z, okay? You do not have any a and b.
yeah, so it's a just
So,
0.
yes,
No.
0, 0, okay? This would be the center. For pi by 6, it would be a line of this type. And for
Pi by 2, it's
pi by,
90, so
yeah, very
straight.
good. Very good, okay? And what exactly it is? It is between these two. So, this is going to be your shaded region between these two lines, right?
Okay.
Is this okay?
Yes.
Right. So for this
And let's
question,
say if it was just less than pi by 2, then even in this case, we have to choose shade the region that's whatever part is less than the other. Like,
yes, yes. Okay, wait,
yeah.
wait, wait. That's a
Okay.
good question. For this one, right? Right? This in this case?
Yes.
Okay. Let me
Yes.
make the y-axis. Just imagine that this is the imaginary axis. Okay, now they are saying that the okay, wait a second. The argument is less than pi by 2. Okay, so that would have been this part. Okay, but not less than that, because less than that could be greater than pi by 2 as well. Okay, are you getting my point, Anjani?
Yes.
The
But
argument,
wait, why are we drawing pi by 6? Because it's saying less than pi by 2, right? So
yeah,
there's
sorry,
no
sorry, sorry,
pi.
this is pi by 6. Yes, this.
Okay, pi by 6. So less than meaning, yeah, that region.
Okay, this
Okay.
would be the area. Yes, so are you okay with it now?
Yes.
Anything that you have not understood now?
No, ma'am, it's fine.
Okay, so it's good that you have understood this. I'll stop the recording and I'll tell you.